Good morning, students. Today we're going to discuss about lesson 2. Okay, today the class was suspended because of the earthquake last night. So please just watch this pre-recorded video in organic chemistry. So today we're going to explore one of the foundational topics in organic chemistry such as structure and bonding. So ano namang importante ni nga lesson? Okay? This lesson is important and essential because understanding how atoms bond and interact will help you grasp more complex reactions later on. Okay, so here are the specific learning outcomes. Determine the number of outermost electron of a given element. Write the electron dot and line bond structures of a given molecule. Determine which elements have weak and strong electronegativity. And then we also have to assign partially positive or partially negative symbols to indicate the direction of expected polarity bonds. And the fifth one, distinguish the types of chemical bonding. So without further ado, let us discuss the development of chemical bonding theory. Okay, so let's take a moment to understand how our knowledge of chemical bonding developed over time. This historical perspective helps us appreciate why molecular shapes matter in organic chemistry. So first, we have Kekule and Cooper independently observed that carbon always form 4 bonds. Kung sa Bisaya pa, ilhang na diskubrihan, ka ang carbon kuno, pero may gyud mo connect sa upat ka lain-lain nga atoms. So dili siya mo band og duha lang, dili lang tulod, kundi kanunay lang jud nga upat. Okay, and then later, Van 't Hoff and Lebel proposed that these 4 bonds are not just random. They have specific spatial directions. Okay? So, ang kanidang mga bonds, just like diri sa ato ang illustration, no? Their bonds have specific spatial directions. So, say for example here, the atoms surround carbon as corners of a tetrahedron. Okay? So, I want you to look at the shape of a regular tetrahedron. Nga namang namura siya tetrahedron? It's because of the direction that these bonds are facing. So, kakita mo aning duha ka hydrogen, okay, labeled bonds in plane of page. Okay, meaning to say, as is ra jud na ilahang direction. Kaning hydrogen sa taas, straight and flat ra jud na siya na nakapoint sa taas. Then kaning hydrogen diri sa lower right side pita, as is rapod na siyang flat rapod ihang direction or diha ra gyud na siya. Okay, man gitawag siyang bonds in plane of page. Then we have here kaning hydrogen diri sa ubos. As what you can see, no? Ang hydrogen diri sa ubos class kay baga siya o bond, right? So heavily wedged or baga ang iyang bond. And that means the bond coming out of plane. Okay? Bond coming out of plane. So, kanang heavy wedge, it shows that bond that is coming out toward us. So, it's almost like it's popping out of the screen. Or in other words, kana siya na bond is pointing towards the viewer. Or kita man ang viewer, kaya kita may galantaw, diba? So, kita ang viewer, kani daw na bond is pointing towards us or that bond is coming out towards us. So, again, kaning bonds in plane of page, it means that these bonds lie flat. So, flat ra gyud na siya in the plane of the page. So, as is ra gyud na iyang direction. Now, how about kaning dashed line? So, kita mo ani, dashed line, okay? Bonds receding into page. So, kaning dashed line, the bond, it represents that a bond going back behind the plane or away from the viewer or away from us. Kapalayo siya sa viewer or nasa likod sa plane or back behind the plane. Okay, so let me just repeat. Kaning bonds in plane of page represented by solid lines, they represent bonds that lie flat or as is ra gyud yung direction diha in the plane of the page. While this heavy wedged bond, so it shows a bond that is coming out towards us or the bond is pointing towards the viewer. And then we have here the last one. The dashed line, it represents a bond going back behind the plane or away from the viewer. All right, so the same explanation in this page. Ano, tungod anang iyahang specific spatial direction, that is the reason why ato ang carbon atom forms a tetrahedral shape. Kung diba, kung mo-bond siya og different atoms or 4 kabog atoms, iyahang shape is mamura siya og tetrahedron. Okay? So, ang solid line o atong Bisaya unsa, ang solid line mao nang bond nga makita nato nga pareho ra sa papel. Ikat ang bonds in page. And then ang wedge kanang murag patambok, mao na ang bond nga nag-atubang nato. While ang dashed line, mauna ang band nga nagpalayo. So, murag nagpalikod sa papel. Mauni ang paagi nga maklaro nato nga naa gyud ay 3D. So, are you familiar with 3D? 3D means three-dimensional, okay? So, ang ato ading mga molecules or organic compounds na aday three-dimensional nga forma bisan sa drawing lang. And dire, atong makita, no, we have here the ball and stick model, okay? This ball and stick model is a physical representation of the tetrahedral carbon atom. So at the center, kaning very dark na ball is the carbon atom. And the 4 hydrogen kanang color gray or lighter ang color niya are at the corners. So 4 hydrogen at the corners. So nakabantay mo ang angles between the bonds are somewhat equal, about 109.5 degrees, so which is the hallmark of tetrahedral geometry. So this tetrahedral arrangement class explains why organic molecules have specific shapes. Again ha, ang organic molecules class na ay specific shapes tungod kay ang mga bond nila na ay specific spatial direction. And why those shapes influence their reactivity and properties. So we have also to keep in mind that structure dictates function. So the way atoms are arranged will always affect how molecules also behave. Okay, let's proceed to the next slide. We have here, all right. Atoms form bonds because the compound that results is more stable than the separate atoms. So meaning, mas ligon ang compound kung nag-combine or nag-bond ang mga atoms kaysa nga mag-separate lang or mag-inusara lang sila. So again, they need to bond so that the resulting compound is more stable. And then, we have here, in salts, ionic bonds form when bonds are transferred from one atom to another. So diri sa ionic bonding, no, marinig usa ka atom nga mo-donate or mohatag og electrons. Then ang usa ka atom mo ay mudawat sa electron. So naatay tig-donate og electron, naapod tay tig-receive og electron. So mao ni ang ionic bond. So katong tig-donate og electron, okay, mao to siya mahimong positive ion or mahimong cation kay ni-lose man siya og electron. Katong nidawat sa electron or ni-receive sa electron, mahimo na siyang negative ion or mahimong anion. Okay? In organic compounds, however, we usually deal with covalent bonds where atoms share electrons. And this idea was actually introduced by G. and Lewis in the year 1916. Okay, so dili po sa covalent bond, wala'y nag-donate og electron, wala po ni-receive og electron. Ang sir man, ang nahitabo, atoms share electron. Okay, mag-share sila para mas stable sila. Mag-share lang sila ng electron para mas stable sila. Okay, and that is covalent bonding. Then we have Lewis structure. So in Lewis structures, we also call this electron dot structures. So it shows the valence electrons as dots, mga tuldok pa. For example, we have hydrogen. Hydrogen has only one dot for its 1s electron, while carbon has 4 dots. Okay? And then we have Kekule structures or line bond structures. So in line bond structures, we can see or observe that a line between two atoms represents two electron covalent bond. Okay, so meaning sa usa ka line na atong makita na ay duha ka buok electrons na nag-form o covalent bond. So kung pananglitan na ay tulo ka lines imong nakita. So na ay 6 ka buok covalent bond. Kaya again, ang usa ka line, it represents a 2 electron covalent bond. Then we also have the octet rule, no? So a stable molecule results when atoms complete their outer shell. Okay? If they are able to complete their outer shell, then at most they have 8 electrons, no? So 8 electrons for most atoms, while only 2 for hydrogen. So again, for the octet rule, so stable molecule results at completed shell. So dapat 8 lang kabuok electrons para makomplete ang ilang outer shells. Now, if makomplete na ilang outer shell, that means they are following the octet rule. Okay? Ano naman kailangan sila mo-follow sa octet rule? Again, para mas stable sila. For example, ang fluorine na siya 7 electrons sa iyahang valence electrons or outermost electron. Okay? 7 ra. Nag-follow ba siya sa octet rule? Wala siya nag-follow. Kay dapat sa octet rule, ang ilahang outer shell dapat 8 electrons gyud para mas stable siya. So meaning si fluorine kulang pa siyang usa ka electron or kailangan siya mo bond sa hydrogen kay ang hydrogen na may 1 dot, no, or 1 electron para makumpleto siya or para ma-follow nila or makomplete nila ang octet rule. Okay, let's proceed to the next slide. All right. So we have here the Lewis structure and electron dot. We have here the Lewis structure or electron dot structure and Kekule structure or the line bond structures. So as what you can see, there is a atong example no, we have NH3 or ammonia. So here sa nitrogen, look at this blue one. Okay, sa nitrogen, there are 5 dots. Meaning to say, ang outermost electron or valence electron is 5. Then, diripod sa atong hydrogen, tagsa-tagsa lang sila og valence electron. So, tagsa rapod sila og dots. Now, if we're going to combine, kung ato siyang i-combine, no, para maka-form siya og compound, ingon ani ang purma, okay, kaning mga dots lang, that is the Lewis structures, then kanina ay mga line, that is the Kekule structure or line bond structure. So, look at the electron dot structure. We can see that there are 5 blue dots nagikan sa nitrogen and then 3 dots gikan sa tulo ka buok hydrogen. So 5 plus 3, does it follow the octet rule? Nag-follow na ba sa octet rule? Yes, na-follow sila sa octet rule. Okay, 5 plus 3 is equal to 8. Now, I want you to look at this line bond structure sa NH3. Pila ka buok lines inyong nakita? Okay, na ay 3 kabuok lines ang inyong nakita, no? And then we have mentioned kanina sa usa ka line, there are 2 electrons that is covalently bonded. So, meaning to say, kaning tulo kabuok lines na ay 6 kabuok electrons na nag-share. Alright, so nag-share. Then, plus na ay 2 kabuok electrons sa taas anang nitrogen. Okay, so 6 plus 2 is already 8. Okay, question, ma'am, nga namang wala na nag-bond ang 2 ka electrons sa taas ni nitrogen? Okay, kanisang mga electrons sa taas sa nitrogen, we call this non-bonding electrons or lone pair of electrons. They are still part, okay? They are still part of the octet rule. Kung ito siyang ihapon ng 6 plus 2, 8 ring hapon. Nag-follow rin siya sa octet rule. Only, kanina electrons sa taas ni nitrogen are not involved in bonding or dili siya involved sa bonding. Manang gitawag rin nato siya non-bonding electrons or lone pair of electrons. Okay, class, let us proceed, no? Sa Bohr model of an atom. So how do we get, okay, we have a question here. How do we get the valence electrons using the Bohr model of an atom? So sayo na kayo, no? So we have to keep in mind, no, that valence electrons are the outermost electrons. So para makuha na to ang valence electrons, we have to draw the Bohr model of an atom. So at the center, kanang pinaka-center, that is the nucleus, no? So it contains the protons and neutrons, kanang nas pinakatunga. And then, after that, you draw the first ring. Kanang first ring, it can hold up to a maximum of 2 electrons. Kay duha ra gyud na ang maximum electrons na pwede ma-hold sa first ring. And then, class, for the second ring, 8 ra pud na ka electrons ang maximum. And then, sa third ring, 18 electrons ra pud ang maximum. And then, fourth ring, 32 electrons ra pud ang maximum. Okay, let's have an example, class. So let's draw the Bohr model of an atom sa carbon. For example, carbon has an atomic number of 6. So which means there are only 6 electrons to plot in the orbital rings using the Bohr model of an atom. So you draw carbon at the center, okay? That means na nucleus na siya. It consists of the protons and neutrons. Then draw the first ring. So again, the first ring will only hold a maximum of 2 electrons. Diba, we need to plot 6 electrons. So 6 minus 2, pila na lang kulang? Okay, 4 na lang ang kulang. So next, draw the second ring. Now, the second ring will contain the 4 electrons. So 2 plus 4 is equal to 6. So sakto na siya. 6 ka electrons siya man ang ato ang need nga i-draw. Mo drawing pa ba tag ikatulo na ring? Yes or no? Okay, dili na ta kailangan mag-drawing og ikatulo na ring kay na-drawing naman nato ang tanang electrons. So duha sa first ring and upat sa second ring. So in this example, the valence electron or the outermost electron of carbon is 4. So kung akong ihapon, no, ang outermost electron niya na nasa second ring, 4 ra gyud na siya. Okay? Then how about fluorine? So fluorine has an atomic number of 9. So tungod kay 9 man yung atomic number, the 9 pud ka electrons ang atong i-plot sa orbital rings. So you draw fluorine at the center, then draw the first ring. So again, the first ring pair mi ra ng duha iyang electrons. Okay, so 9 minus 2 pilay ko lang. Okay, 7. So we need to draw the second ring. So sa second ring, okay, it will now contain 7 electrons. Kaya pila gani ang maximum sa second ring? Okay, ang maximum sa second ring is 8 electrons. But in this case, sa fluorine, 7 electrons ra. Okay, so 2 plus 7 is equal to 9. Okay, kompleto na ni siya because we only need to plot 9 electrons. Alright, so in this example, the valence electron or the outermost electron of fluorine is 7. So, kailangan pa ba ta mo-drawing og ikatulong nga ring? Okay, dili na ta kailangan mo-draw og ikatulong na ring. Kina-complete naman nato siya. 2 plus 7 is equal to 9. But if we're going to count the outermost electron, no, na naa sa second ring, 1, 2, 3, 4, 5, 6, 7. So, the answer is 7 na yung valence electron or the outermost electron. Okay, let's proceed. Atoms with 1, 2, or 3 valence electrons form 1, 2, or 3 bonds. Okay? And then we have atoms with 4 or more valence electrons form as many bonds as they need electrons to fill the S and P levels of their valence shells to reach a stable octet. Then we have carbon has 4 valence electrons, so it can form 4 bonds. Then we have nitrogen has 5 electrons, but forms only 3 bonds. So in the case of NH3, kita tanon na iyang bonds kay tulo ra ka buo. No, although na siya 5 electrons, pero ang bonds ra na form is 3. And then we have oxygen. Oxygen has 6 valence electrons, pero it will just only form 2 bonds, duha ra. So let's proceed to the next slide para ma-visualize yun ninyo nga naman na ang NH3 tulo lang, okay, or ang nitrogen tulo ra ka bonds, ang oxygen nga nara kung duha. Then we have various examples here lang tawa, no? Electron dot structures and the line bond structures of methane, ammonia, water, and methanol. So let's zoom in para klaro ha. Let's first examine methane. So the valence electron of carbon is 4. That's why it will always form 4 bonds. So carbon is color black, right? Color black si carbon. That's why we can see that there are 4 dots na color black. And then we have 4 hydrogens na color green. Okay, color black is 4, then 4 kabuk green na dots. So 4 plus 4 is equal to 8. So yung ana ang iyahang forma sa electron dot structure of methane. And then we have here the line bond structure of methane. So pila ka buok linya or pila ka buok lines inyong nakita. Yes, naaray 4 bonds or 4 lines. Since there are 4 bonds, so this means na there are 8 electrons sharing. No, 8 ka buok electrons ang nag-share. So na may 4 bonds. Then we have ammonia. So look at the electron dot structure of ammonia, no? 5 kabuok blue from nitrogen and 2 kabuok green from hydrogen. So 5 plus 3. Okay, 5 plus 3 is equal to 8. So yes, it also follows the octet rule. But looking at here, there is a line bond structure niya. We can only see na naray 3 kabuok lines. Okay, 3 ra gud kabuok lines. So this means that there are 6 electrons that are covalently bonded or 6 ka electrons nga nag-share. So kanang duha ka buok electrons on top of nitrogen, again we call that non-bonding electron or lone pair of electron. Okay, let's proceed to water. So ang water, we have here oxygen. The valence electron of oxygen is 6. So we can see na 6 kabuok pink dots. Okay, 6 kabuok pink dots. And then duha kabuok green dots from hydrogen atoms. So 6 plus 2 is equal to 8. So nag-follow kaya siya sa octet rule. But pag abot diri sa ubos, okay, sa yung line bond structure, we can only see na naaray duha kabuok lines. Okay, or duha ra kabuok bonds. So this means there are 4 electrons sharing. Okay, naray 4 electrons na nag-share. Alright? So, unsa man ang mga electrons na wala nag-bond kanang lone pair of electrons sa taas and sa ubos. So, those are non-bonding electrons. So, naday tayo duha ka pares sa non-bonding electrons. Okay, so duha ra jud siya ka bond na form diri sa water. Okay, just remember ha, ang oxygen, it has 6. Okay, it has 6 valence electrons, pero ang bonds na na-form kay duha ra gyud. And then we have methanol. Okay? I want you to look at methanol, no? The chemical formula is CH3OH. Again, let us examine carbon first. So, si carbon, iyahang valence electron is 4. So, upat ka buok black dots. And then we have oxygen, unom ka buok, pink dots. And we have 4 hydrogen, okay, 4 hydrogen. So upat pud ka buok or tagsa-tagsa sila og dots. So let us look at carbon first. Carbon is bonded to oxygen on top, bonded to the carbon is bonded to the hydrogen on top, and then carbon is also bonded to the hydrogen diri sa left side, and then hydrogen bonded also to the hydrogen diri sa ubos, and then carbon is bonded to oxygen diri sa right side. Okay, so 4 electrons from hydrogen plus 3 electrons sa hydrogen. Let me repeat that, no? 4 electrons from carbon, okay, 4 electrons from carbon plus 3 electrons sa hydrogen. So 4 plus 3 is equal to 7. And then plus 1 electron na gikan sa hydrogen. So yes, it follows the octet rule. Okay, now if we're going to look at oxygen, okay, lang tawag may si oxygen ha. So oxygen has 6 electrons, no? And it is bonded to carbon diri sa left side and bonded to hydrogen diri sa right side. So 6 plus 1 electron from carbon and 1 electron from hydrogen. So 6 plus 1 plus 1 is equal to 8. So yes, it still follows the octet rule. Okay, lantawan na po ang iyahang line bond structure diri sa ubos, ang methanol. Diri sa ubos na po ha. Pila ka book lines ang makita? Okay, 5. There are 5 lines or 5 bonds. Okay, 5 bonds ha. So meaning to say, 10 ka buok, okay? 10 ka buok electrons ang nag-share. Then atong makita no sa oxygen na ay duha ka pares nga non-bonding electrons. Okay, let's proceed na po diri sa ubos no. So we have here hydrogen. Since ang iyahang valence electron is only 1, hydrogen will always form 1 bond. Then we have carbon, iyahang valence electron kay 4. That's why ang iyahang ma-form na bonds pero may kay 4 rapod. Then we have nitrogen. Nitrogen has 3 bonds. And then na siya usa ka pares nga non-bonding electrons. Then we have oxygen, atong makita. Although iyahang valence electron is 6. Okay, ang oxygen no, iyahang valence electron is 6. Pero ang bonds ra nga iyahang ma-form kay duha ra. Pero naa siya duha ka pares nga non-bonding electrons. And then we have here fluorine, chlorine, bromine, and iodine. These are all halogens, no? Fluorine, chlorine, bromine, and iodine, these are halogens. And ang ilahang valence electron is 7. Tungod kay 7 man, ilahang valence electron, kulang na lang sila usa ka buok electron para mas stable. So 7 valence electrons tuod ang naa nila, but they can only form 1 bond. Okay, 1 bond na lang ilang ma-form. Okay, please remember that one ha. Now let's proceed to the non-bonding electrons. So ako naman yung storya ganina, no? Non-bonding electrons, or these are the valence electrons not used in bonding or not included in bonding. So we call them non-bonding electrons or lone pair of electrons. For example, ang nitrogen ganina sa ammonia na in NH3. So it shares 6 valence electrons in 3 covalent bonds, and the remaining 2 valence electrons are non-bonding lone pair. So again, ato makita diri sa taas no kanang arrow, non-bonding or lone pair of electrons. So ato rang bonds na makita kay tulo ra ka buok, meaning to say there are 6 electrons na nag-share, so forming 3 covalent bonds. But in other books, class, paraan no kani sa taas anang nitrogen, wala na nila gidrawing ang non-bonding electrons kay murag understood na ay non-bonding electrons on top of nitrogen. So the same with kuan kaning water, no? The same with water. Usahay kuan ra HOH ra makita, wala na gidrawing apil ang mga non-bonding electrons kay understood na ay non-bonding electrons. Okay, now let's talk about how covalent bonds actually form. So according to the valence bond theory, a covalent bond forms when 2 atoms come close enough that their singly occupied orbitals overlap. So when this happens, the electrons in those orbitals are paired and are attracted to the nuclei of both atoms. So a classic example of this is the hydrogen-hydrogen bond in hydrogen gas or H2. So each hydrogen atom has one electron in its 1s orbital, and when they overlap, they form a stable bond. So let me repeat that. Each hydrogen atom, kaning sa H2 or hydrogen gas, they have one electron in its 1s orbital. So tagsa silang electron sa ilang 1s orbital. And kung mag-overlap sila, they will be able to form a stable bond. So this bond is cylindrically symmetrical around the axis between the two nuclei, and we call it a sigma bond. Okay? So kung ano, bisayaon entirely para masabtan sa tanan, ang duha ka hydrogen atom or kaning H2, matag usa na ay usa ka electron nila. Kung magduol sila, ang ilang electron magtapad o mag-share. So mag-overlap ba, tapos mag-share sila electrons. So mo ni ang mahitabo na na-form ang H2 molecule. Ang bond nga ilang gihimo gitawag nga sigma bond, mura bag ligid nga nagpalibot sa axis sa duha ka atoms. So sa diagram natong nakita diri, no, the two 1s orbitals are overlapping. So the resulting bonding orbital that holds the two electrons between the nuclei. Okay? So we have here a worked example of drawing electron dot and line bond structure. So draw both electron dot and line bond structures for chloromethane. Okay, so the chemical formula of chloromethane is CH3Cl. So natin strategy diri na sundon, class. So remember that a bond that is a pair of shared electrons is represented as a line between atoms. So sa ganito, sa usa ka linya, it represents two electrons na nag-share. Okay, so ang solution, unsaon ni nato pag-drawing? So unsa tong given na formula, CH3Cl. So the hydrogen has one valence electron, di ba? Ang hydrogen, iyang valence electron kay usara. Then carbon has 4 valence electrons. So ang carbon ay upat ka buok valence electrons. And chlorine or ang Cl has 7 valence electrons. Okay? So thus the chloromethane is represented as like this one kaning nasa drawing sa ubos. Ingon ana siya. So, one carbon atom at the center, tulo ka buok hydrogen atoms located, and today, sa right side, or sa usa ka side is Cl. So, pila ka buok bonds atong nakita tanan? Na ay upat ka buok bonds. So, meaning there are 8 electrons that are sharing. Pero kung atong i-drawing tong mga non-bonding electrons na nasa chlorine, naatay 3 pairs or tulo ka pares na non-bonding electrons sa chlorine. Kaya naakilid sa chlorine ay 3 pairs or unong ka buok electrons tanan ang wala ng pair. So this is the chloromethane. Okay, mao ni siya, no? Mas giklaro na itong gibutangan na itong color para mas masabtan. How about the electron dot structure and line bond structure of methane or CH4? So 1 atom of carbon and 4 atoms of hydrogen. And remember, we have here carbon, Ve. What is Ve? Valence electron. So the carbon has a valence electron of 4, kanang color blue. And then hydrogen, V ang valence electron kay 1. Okay, so we need to draw the electron dot structure and line bond structure of CH4. So sa tunga diha class, butangan nato og carbon. And unsa gani color sa valence electron ni carbon? Red or blue? Color blue. Okay? So you draw upat ka buok color blue nga dots. So pila na lang ka buok kulang para maabot og 8. So yes, kailangan siya upat ka buok hydrogen para ma 4 plus 4 is equal to 8. So we need to draw 4 hydrogens, tapos drawingan po nato og 4 ka buok nga red dots. Okay, so 4 ka blue dots from carbon and 4 ka buok red dots from hydrogen or electron dot structure. Now, kung ato ang i-drawing ang line bond structure, so ingon ani ra upat ka buok line. So meaning sa usa ka line or usa ka bond, there are 2 electrons na nag-share. So dili upat naman ni ka buok lines or upat na ka buok bonds. Meaning, naanay 8 ka buok electrons nga nag-share. Okay, class, let us proceed to bond energy. So ato ra ning i-simplify, no? By the way, ato siyang i-recall kung ubang mga terms, no? Again, non-bonding electrons or lone pairs. But pasabot, these are electrons in the outer shell that do not participate in bonding. Munang gitawag sila non-bonding electrons. And katong sa valence bond theory, so I hope you can still remember, no? Ang valence bonds theory, ingon sila dito na ang bonds kuno ma-form when orbitals from two atoms overlap and electrons are shared. So for example, kato ganina, duha kay hydrogen atoms nag-overlap and then their 1s orbitals to form H2. Now let's proceed to bond energy or bond strength. Musa may but pasabot ani. So the bond energy, this refers to the energy required to break a bond. Okay, energy required to break a bond. Okay, so ato makita din no, the energy is released when bonds form. But if the energy is absorbed, the bond breaks. Okay, so again, bond energy is the energy required to break a bond. Then we have here stronger bonds. Okay, kung stronger ang bonds, that means more stable ang mga molecules. Okay, kung lig-on ang bond, kung strong ang bond, mas lisod siyang ma-break. Kunya lig-on pud ang molecule or strong pud ang molecule. Is that clear? And then we have here another term, bond length. Okay, bond length. This is the distance between nuclei that leads to maximum stability. If ang distance no sa atong bonds is too close or kung dugo na siya kaayo, they repel because both are positively charged. So kita mo ani, kana di ba dugo na siya kaayo, mo repel na siya because both of the hydrogens are positively charged. But if too far apart, the bonding is weak. So kanipod kaning hydrogen kita ninyo, layo ra kaayo siya. So ang iyang bonding is weak. So diri, ang ideal ra gyud na bond length is 74 pm or 74 picometer. So dili pud siya kaayo close, di kay siya dugol, dili pud siya kaayo layo. So the bond length is just appropriate. So dili siya dali-daling mo repel, dili pud siya dali-daling ma-break, dili ma siya weak. So in simple terms, class, bond length refers to the distance between two bonded nuclei. Let me repeat that. Bond length refers to the distance between two bonded nuclei. And this also means that stronger bonds are usually shorter. Okay, stronger bonds are usually shorter. Pero dili po tong dugol kaayo na bonds kay mo repel ra gyud sila. Then dili po siya pwedeng layo kayo or too far ang bond kay dili ra po siya ma-break kay weak ra man. Okay, I hope that is clear. Then we have sp3 orbitals and the structure of methane. Okay, what do we mean by sp3? Okay, kaning sp3 hybrid orbitals, it means that carbon mixes 1s, unsa ning s, katubang nakahinumdum mo ato ang orbitals sp-d and f orbitals. Okay, so sp3 hybrid orbitals means that carbon mixes 1s and 3p orbital. So usa ka s and tulo ka buok p orbital. So manang gitawag og sp3 hybrid orbitals. So these form 4 equal bonds with hydrogen and the shape itself is tetrahedral. So no, ang carbon ba murag nag-andam og upat ka buok nga parehas nga kamot or bonds para makagunit sa upat ka buok hydrogen. Kamo ni siya dili. So s orbital and 3 orbitals combine to form 4 equivalent unsymmetrical tetrahedral orbitals. And then next let's proceed to the structure of methane and its bond angle. So ang bond angle sa methane is 109.5 degrees. So nga naman yung 109.5 degrees, class, because this angle keeps the bonds as far apart as possible. Okay, so sp3 orbitals on carbon overlap with 1s orbital on 4 H atoms or 4 hydrogen atoms to form 4 identical carbon-hydrogen bonds. Okay, so this methane or kaning methane has a bond strength of 436 kilojoule per mole and bond length of 109 picometer. Then iyang bond angle, no, ang ideal niya is 109.5 degrees, and because of this it forms a tetrahedral angle. Okay, let us proceed to the sp3 orbitals of the structure of ethane. Okay, so we have here two carbons bond to each other by a sigma overlap and an sp3 orbital sigma overlap of an sp3 orbital from each. So 3 sp3 orbital forms. Okay, so we have here 3 sp3 orbitals on each carbon overlap with hydrogen 1s orbitals to form 6 carbon-hydrogen bonds. So, ang carbon-hydrogen bonds, kina ay bond strength in ethane na 423 kilojoule per mole. So, muna yung bond strength. And then, yung length or bond length is 154 pm or 154 picometer. Okay? And all bond angles of ethane are also tetrahedral. Okay, so another information that I could add is that each carbon is sp3 hybridized. So they form a carbon-carbon sigma bond. What do you mean by sigma bond? It is single bonds, no? Carbon-carbon sigma bond or single bonds plus bonds to hydrogens. So that's why tungod sa iyang bond strength, iyang bond length, and iyang bond angles, naka-form siyang tetrahedral around each carbon. And then let's proceed to sp2 orbitals and the structure of ethylene. Okay, so in here, sp2 hybrid orbitals, we have 2s orbital combines with 2p orbitals, giving 3 orbitals or spp or sp2. So this results in a double bond. So sp2 orbitals are in a plane with 120 degree angles. So the remaining p orbital is perpendicular to the plane. So this is the sp2 orbitals and structure of and the structure of ethylene na C2H4. Each carbon is sp2 hybridized, meaning sa may pasabot sa sp2 hybridized class na ay 1s and 2 ka p orbital. So usa ka s orbital and duha ka buok p orbitals. So sp2 orbital meaning sp2 hybridized, 1s orbital and duha ka buok p orbitals. So 3 or tulo ka buok sp2 orbitals form sigma bonds. So the leftover p orbital forms a pi bond. So pi bond class or pi, di ba? Familiar mo pi sa math, di ba? So pi or pi bond is a double bond. So katong sigma bond na akong giingon kanina, single bond dry ma-form ato. Pero sa pi bond, it forms double bond between carbon atoms. And then let's proceed to the bonds from sp2 hybrid orbitals. Okay? So two sp2 hybrid orbitals overlap to form a sigma bond. Again ha, ang sigma bond is single bond and p orbitals overlap side to side to formation a pi bond. Ang pi bond is double bond. So sp2 sigma bond and 2p2p pi bond result in sharing 4 electrons and formation of carbon-carbon double bond. So electrons in the sigma bond are centered between nuclei and electrons in the pi bond occupy regions are on either side of a line between nuclei. So this means that a pi bond or a double bond will form when unhybridized p orbitals overlap side by side. Okay, so double bond is equal to 1 sigma plus 1 pi. Okay, so kung sa Bisaya pa kaning pi bond mura siya og extra lock. Okay, extra lock nga nagpadugang og ligons ato ang double bond. Now we have the structure of ethylene. Okay, hydrogen atoms form sigma bonds with 4 sp2 orbitals, and we have HCH and HCC bond angles of about 100 degrees, and we have carbon-carbon double bonds in ethylene shorter and stronger than single bond in ethane. And ethylene na carbon double bond carbon, the length is 134 picometer. Okay, so kining sa structure of ethylene, ang iyahang structure kay flat or mura siya planar, and yes, the bond angle, ang iyang pinaka-ideal na bond angle is 120 degrees. So mura siya og triangle arrangement, no? Okay, so let's proceed to the sp orbitals and the structure of acetylene. So carbon-carbon, a triple bond sharing 6 electrons. So carbon, 2s orbital, hybridizes with a single p orbital. And then we have sp orbitals are linear and the ideal bond angle is 180 apart on x-axis. Then we have 2 p orbitals are perpendicular on the y-axis and the z-axis. So, diri sa acetylene, each carbon is sp hybridized. So, sp hybridized meaning usa ka buok s orbital and usa ka buok p orbital mo ng sp ra. sp hybridized. So, 2 sp orbitals form sigma bonds. So, kung naay duha ka buok sp orbitals, this will form sigma bonds. So, 2 leftover p orbitals form 2 pi bonds. So, ang resulting ani na bond is triple bond between carbons. Okay? We have orbitals of acetylene. We have 2 sp hybrid orbitals from each carbon form sp-sp sigma bond. So we have pz orbitals from each carbon form a pz-pz pi bond by sideways overlap, and py orbitals overlap similarly. Alright, so as what we can see, the geometry of acetylene is linear, and yes, the ideal bond angle is 180 degrees for this type of orbital. Then we have the bonding of acetylene. Since the bonding of acetylene involves sharing of 6 electrons, it will form carbon-carbon triple bond. Now, kaniyang triple bond, it is composed of 1 sigma bond and 2 pi bonds. So, kaniyang triple bond ha, I will repeat, it consists of 1 sigma bond and 2 pi bonds. Tungod kay triple bond naman ni siya, okay, the bond is very strong and very short bond. Okay? Yes, short bond siya, very strong, but ang ihang distance or ihang bond length is not too close. Kaya again, mo repel na siya. And look at that one, no? The length or the distance between hydrogen and carbon is 106 picometer. And then we have the distance between carbon and carbon at triple bond. We have 120 picometer. And then the bond length, no? Or sorry, the bond angle is 180 degrees. Okay, we have here comparison of carbon-carbon and carbon-hydrogen bonds in methane, ethane, ethylene, and acetylene. So, dili na nako sa usahon ha, kamo nalay basa ana. Okay, so we have here the bonds are given, and then ilang pong bond strength and bond length. So, just familiarize those terms. And then we have hybridization of nitrogen and oxygen. Okay, we have your elements other than carbon can have hybridized orbitals as well. So we have hydrogen, nitrogen, hydrogen bond angle in ammonia or NH3 with a bond angle of 107.3 degrees. And then we have carbon, nitrogen, hydrogen bond angle is 110.03 degrees. So nitrogen orbitals or N's orbitals, sp-pp hybridize to form 4 sp3 orbitals. And we have 1 sp3 orbital is occupied by 2 non-bonding electrons, and 3 sp3 orbitals have 1 electron each, forming bonds to hydrogen and CH3. So we have here example methylamine. Okay, so remember has a nitrogen. The nitrogen in ammonia or NH3 is sp3 hybridized, so with 1 lone pair of electrons. Then we have oxygen and H2O or water. Ang oxygen is sp3 sp3 hybridized with 2 lone pairs of electrons. So lone pairs push bond closer or makes the bond angles smaller. Okay, let's proceed to the molecular orbital theory. So a molecular orbital theory means where electrons are most likely to be found, or the specific energy and general shape in a molecule. And then we have additive combination, or that means bonding. So molecular orbital is lower in energy. Kung subtractive combination or anti-bonding, the molecular orbital is higher in energy. So let us simplify this one. So instead of orbitals overlapping, the molecular orbital theory says orbitals combine to form new molecular orbitals. So sa additive combination, we have bonding orbital. Ang bonding orbital is stable and it consumes lower in energy, or it has lower energy. Dili tayo consume castor ha. Lower energy lang siya ang additive combination, and the bonding is stable. And then sa subtractive combination, anti-bonding orbital na siya, and the bonding is unstable. So dili stable ang subtractive combination, and it also has higher energy. Okay, then we have types of chemical bond: ionic bonding, covalent bonding, and polar covalent. So this ionic bond, in the case of NCl, there is a transfer of electron, and ionic bonding occurs between metal and non-metal. So we have sodium atom, this is our metal, and chlorine atom, our non-metal. So si sodium nilusog electron or nag-transfer ang usa ka electron gikan ni sodium paingon kay chlorine. Now, si sodium, nakuha na siya usa ka buok electron. Si chlorine, ni-gain or nandungagan na siya usa ka buok electron. So, sodium now becomes a positive ion, or it becomes a sodium ion or a cation. Then si chlorine, himo na siyang negative ion, or it becomes chloride ion, which is also an ion. Okay, basta has ionic bonding, there is a transfer of electron na ay nilusog electron apoy ni gain of electron. Ang nilusog electron nahimo siyang positive ion or cation. Ang ni gain of electron nahimo siyang anion or negative ion. Then next, we have the covalent bond. So this is a type of chemical bond wherein two or more atoms share one or more electron pairs. So diri no lang tawa ang methane, ethane, and propane. Walay ni transfer ng mga electrons pero puro ra sila nag-sharing of electrons. Sa methane, pila ka bonds inyong makita or pila ka lines? Okay, there are 4 lines or 4 bonds. Since 4 bonds man na ay 8 kabuok electrons nga nag-share. How about sa ethane class? Pila man kabuok bonds atong nakita? Let's count ha. 1, 2, 3, 4, 5, 6, 7. So there are 7 bonds, meaning na ay 14 kabuok electrons na nag-share. How about sa propane class? Let us count the number of bonds sa propane. 1, 2, 3, 4. Again ha, sa propane, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So na ay 10 kabuok bonds sa propane, meaning to say 20 kabuok electrons ang nag-share. Okay, basta covalent bonding gani, sharing of electrons. Okay, kana. Okay. Then we also have types of covalent bond. Natin mga single bonds, pwede silang maka-form og single bonds, pwede maka-form og double bonds, pwede po maka-form og triple bonds. Sa single bonds, nag-share og 2 kabuok electrons. Sa double bonds, nag-share og 4 kabuok electrons. Sa triple bond, nag-share og 6 kabuok electrons. Okay. We have polar covalent bond. So these bonds that are neither fully ionic nor fully covalent but are somewhere between the two extremes. So dili siya ionic, dili po siya fully covalent. So nara siya tunga-tunga. So meaning these bonding electrons are attracted more strongly by one atom than the other, so that the electron distribution between atoms is not symmetrical. So look at this example, class. So in figure 1.13, it shows the continuum in bonding from covalent to ionic is a result of an unequal distribution of bonding electrons between atoms. The symbol kanang murag S, no? Murag S na ay positive and minus, no? We read that as partially positive and partially negative, meaning partial charge, either partial positive for the electron poor atom or partial negative for the electron rich atom. So sa covalent bonding, lantawa ang shape sa molecule and lantawa ang atom. So atom X and X equal ra, no? Nag-share sila og electrons. So ang ilang electrons nara sa tunga nag-share. So symmetrical ra or balance ang ihang shape sa covalent bond. But look at the shape sa ionic bond. We have atom X and atom Y. Si atom X na siya positive charge, si atom Y na siya negative charge. Si atom X is electron poor, si atom Y is electron rich, no? Diha sa ionic bond. And then kung atong makita sa ionic bond, separate ang ilahang molecule. Separate ha, di ba? Nakita ta duha ka buok separate molecule. Pero sa covalent bond, usa ra gyud ka buok molecule ang na-form, nag-share man gud sila. Pero sa polar covalent bond class, nang tawa ang polar covalent bond sa tunga. We have atom X and atom Y. Si atom X is partially positive nga naman, electron poor man siya. And then si atom Y is partially negative, kay electron rich man siya. But look at the shape, dili symmetrical ang shape or dili balance iyang shape. Diba? Gamay-gamay lang siya diri sa side ni atom X, then dito ni atom Y is dako-dako siya. It's because of the unequal sharing of electron, okay? Unequal sharing of electron, polar covalent bond. For dili siya fully ionic, dili po siya fully covalent, para siya somewhere between sa duha or tunga-tunga lang siya. Now, let's proceed to electronegativity. I know, nakabasa na mo ani, no? So, ato na lang i-simplify ng electronegativity. Unsa din siya? The ability of an atom to attract electrons in a bond. Let me repeat that. The ability of an atom to attract electrons in a bond. So, for example, fluorine sa atong periodic table, ang pinaka electronegative or most electronegative, kay iyang electronegativity is 4.0. Tapos ang pinaka least electronegative kay cesium, kay iyang electronegativity is 0.7 naman. Okay, so diri sa ato ang figure 1.40 na tay electronegativity values and trends. Okay, so lantawan na ninyo, no? Ang cesium or CS 0.7 kay ang electronegativity, pero ang fluorine, ang tawa ang fluorine na diri sa right side 4.0 gyud. Okay, so most electronegative si fluorine. Now we have here no kanina symbol. So partial positive is represented by the symbol, partial negative is represented by this symbol. And then we have the inductive effect. So an inductive effect is simply the shifting of electrons in a sigma bond in response to the electronegativity of nearby atoms. So in simple terms, the pulling or pushing of electrons along a chain of atoms due to electronegativity difference. So this is why some groups make molecules more reactive. Tungod sa inductive effect, some molecules are more reactive. It's because of the pulling or pushing of electrons along a chain of atoms due to electronegativity differences. Okay, and inductive effect plays a major role in understanding chemical reactivity. So, muna ganing reactive kayong ubang molecules. So we have here worked example predicting the polarity of bonds. So predict the extent and direction of polarization of the OH bonds in H2O. So look at the electronegativity table in figure 1.14 to see which atoms attract electrons more strongly. So ang given is H2O or water. So oxygen, ang yang electronegativity is 3.5. So more electronegative na yun siya compared to hydrogen. Kaya ang electronegativity ni hydrogen is just 2.1. So diba 3.5 is higher than 2.1. And then we have here the difference in electronegativities, no? Atong kwaon. So 3.5 minus 2.1 is equal to 1.4. And this implies that an OH bond is strongly polarized. So ingon ani no, kung ato i-drawing ang partially positive and partially negative, diri sa oxygen, drawingan gyud na ato partially negative, and diri sa atong mga hydrogen, drawingan gyud na siya partial positive charge. Kaya nga namang partial negative si oxygen, kaya ang electronegativity is 3.5, diba? And then si hydrogen, pila ganito iyang electronegativity is just 2.1. So we will draw partially positive kay hydrogen. So we have drawing structures. So drawing every bond in organic molecule can become tedious. So some or several shorthand methods have been developed to write structures. So condensed structures. Ako ana ning natudlo ninyo, di ba? Katong sa sinugdanan palaman. Na katong taas na kayo nadaghan na kayong CH2, 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 pwede itong ibutang sa parentheses para ma-shorter siya o palangitan kaning diri siya. Diba? Parentheses CH3, close and open parentheses CH3, tapos na I2, meaning to say na I2 kabuk CH3. So yung ana lang, condensed structure. Kani ang molecular structure. Kana molecular structure, kani ang condensed structure. Okay, so kamo ni bahala og basa anang drawing the structures. Alright, that would be all for lesson 2. Kamo ni bahala pong read sa summary. And thank you so much. And please expect a summative exam by next week. Okay, thank you and good luck, dear students. Again, please study and prepare for the second summative exam next week. Okay, goodbye, class.